Hello, container fans. Welcome to the show. If you haven't been here live before, thanks for being here. This is where I get to have guests most weeks, and sometimes we don't have guests, but usually I do, like today. And we talk about everything DevOps, cloud native, containers, Kubernetes, Docker, all those buzzwords. That's what this channel's been about for the last 3+ years. So thanks for being here. If you're watching this after the fact, come back on Thursdays at 1 o'clock U.S. Eastern. I think that's -4 UTC, something like that. I don't remember all the things time-wise, but it'll be on this channel. So you can just click the reminder button. And if you subscribe and click the dinner bell thingy here on YouTube, you can get notifications when this happens again next week. So before we get to our special guest, a couple of announcements. One, if you didn't know, this is a member-sponsored show. So this turns into this live stream turns into a podcast. And you can listen to that podcast, links below. And you can, of course, get all the things above. All this stuff is supported by members. There are no ads except my own. And those are over on Patreon. So you can go to patreon.com/Bret Fisher. You can sign up. You can follow me there for a newsletter, basically just what I'm creating, what I'm releasing, what's on the podcast this week, what's on the live show this week, what new demos or examples on GitHub I'm creating. You don't have to give me any money if you don't want to. You can just click the follow button. But if you'd like some extra benefits like our monthly High Fivers Hangout, you can buy me a coffee, essentially. And this High Fivers thing is actually, I'm very proud about it because it's turned into the regular DevOps discussion for like an hour or so. Once a month, we all get together, gather in Discord, and we hang out on video. And it's all DevOps practitioners. So it can, one week we might be talking about Kubernetes struggles, or the next week we might be talking about careers and how to, I think last time we talked about how do we learn in this world of constantly new all the time? How do we all stay up to date? And that was a really great topic. So please join us there. Of course, that's all in Discord, which you can get right above me at devops.fan. We just passed 11,000 members. Very exciting there. All hopefully people doing and learning DevOps. Last thing, very excited. Last month, we just launched something we've been working on for almost a year, is the loot box or the merch store. So you can go here to buy all your favorite designs. I only have 4 or 5. We've been working with a couple of designers. We've got more coming, but I'm excited here about what the potential is and what we're going to be releasing soon. We were just actually talking a few minutes ago about SneakerNet. In case you didn't know what SneakerNet was, it was a thing back in the 90s. We would actually walk our stuff from one computer to another because it would be faster than using the network. Back when we had 10 base T and it wasn't switching, it was hubs and it was really slow. So we called it SneakerNet. So we made a shirt about it. So maybe for some of you that are younger, you don't have the luxury of knowing SneakerNet. But anyway, there's other stuff here too. Check it out. That's the link again is below for the store, and you'll probably will see some merch advertised in this show. But enough about all that stuff. Let's get to why we're all here to meet and talk to Liz Rice. Hello.
Hi. I love those t-shirt designs. I might have to order some. I want the SneakerNet one. I want the bare metal one. They're great.
Yeah, the bare metal one is designed. Thank you for that. The bare metal one was motivated around people that have to deal with physical infrastructure, and so we tried to design it like a concert t-shirt. And it's on multiple levels. It's actually a bear playing a keyboard guitar, which is not a. There are keyboard guitars from like the 80s or whatever, but this is a real PC keyboard, and we debated on should it be bear spelled like the animal bear or spelled like bare metal would be spelled. So we went back and forth, and anyway, that's a lot of fun. And I have some great friends that are designers that were working on this stuff. The one that's actually the most popular is the Fix Something Every Day, which I'm getting into a poster to put on my wall because it's kind of been that's why I got into this, to improve things, make things better, help people. And so I was trying to think about what is the phrase that would be me if I put it on a shirt? And that's kind of what this turned into. So I have a coffee mug now, which I sadly don't have in front of me. So yeah. Anyway, those that are HTML people might actually notice that there's a slash there at the beginning that shouldn't be. So that's technically, people are like, is there something in this design?
And I didn't want to say.
Yeah, that's kind of the point. It's like
No,
it
it's been
needs.
a long time since I've done any HTML.
Yeah, it needs to be fixed essentially. And what's funny is the designer's not necessarily a developer, and they did it like that. And I thought, no, we're going to keep that because someone who's looking at it may go, this shirt needs fixed. So that's why we did it. Yeah. Well, thank you so much, Liz, for being on the show. For those that do not know Liz, she has been on here at least once before. We met way back in the early days of Docker because we both could not shut up about Docker. She has one of my favorite all-time talks where she creates a container runtime live on stage in front of you and basically shows you how little there really is to the basics of what Linux containers do. And you don't do that anymore, do you? Do you still do that on occasion, or?
I haven't done it for a while. If it would take me a little while to just remember all the code. So I won't just whip that out now. But it's fun. I really enjoy doing that.
Yeah. I was very entertaining and actually just surprising to those of us that don't code all day for a living. What you could do with just a few lines of code with the Linux kernel, and how much. Granted, it wasn't Docker, it wasn't the complete full set of Docker features, but it was surprising how little you needed in order to take advantage of some of these features like C names and namespaces, or C groups and namespaces.
C groups, yeah.
And we have, of course, other people on the show in the chat. We've got regulars like Martin and Owen and Maz and Eric. Eric is actually, I think he's at a conference.
So I know that he was at Container Days in Hamburg earlier this week.
Yes.
I saw him there.
Oh, okay. Yeah. Well, sadly, I left too early. I was there just weeks ago in your neck of the woods. But so if you didn't know what else Liz does, she loves eBPF. So that's why we're here today. If you don't know what eBPF is, we're definitely going to get her definition. First, I'm going to say this later, but I just want to pimp her books real quick because she is an author of all of the great things about Linux and containers. Last time she was on this show, we were talking about her container security book, which is now completed, right? Like that's finished?
Oh, yeah. That's been out for a while now. So, yeah.
Yeah. And now you have the new report on eBPF, which is it? Should I be announcing that you're working on a book, or is that supposed to be a secret?
We can say that. Yeah. It's I think very soon there will be some early release chapters available. So what is eBPF is a small report. And then I'm writing another one, which provisionally it's called Learning eBPF. And it's going to dive quite a lot more deeply into the kind of topics that what is eBPF covers, but we're going to just go under the covers quite a lot more.
All right. I'm going to put this link in chat. Get the eBPF report. And so for those of you who came here for eBPF, like Ashish, sorry if I'm mispronouncing that name, we are not going to give you demos on eBPF necessarily, but we are going to talk about what it is and what it isn't, and maybe show off some examples. So I still feel like I'm very new to eBPF. Like I maybe have been using it, not even intentionally. It's just happening now in the tools that I use. What can you give me a brief history of that? Like how did that start out, and how is it different today than not having eBPF?
Yeah. So most of us probably have used BPF one way or another. Things like TCP dump is using BPF. Setcomp is using BPF. So, back in the day when I was talking about container security, I would be talking about setcomp profiles quite a lot. And those have been implemented using BPF for quite some time. Nice. So BPF and eBPF, I think, they're used interchangeably, those two terms. So BPF stands for Berkeley Packet Filter. It used to be about packet filtering. Then it was extended. That's the E in eBPF. And now we basically say, the acronym doesn't really mean anything because it does so much more than packet filtering that, might as well forget the acronym. And it's just a thing called eBPF that lets you dynamically program the kernel. We can load programs into the kernel, attach them to events, and measure those events, modify network packets, change the behavior of the kernel, prevent malicious activity. There's all sorts of really cool things that we can do with eBPF by modifying the way the kernel behaves.
And this is something that was unique when it first came out, because previously, didn't we have to like rebuild the kernel if we wanted to do extra things with it?
Yeah, pretty much. I mean, there was kernel modules which you can load. I remember the time when you had to reboot your machine when you put in a new kernel module, but you can load them dynamically. Yeah. But a lot of organizations are quite wary of using kernel modules. And the reason for that is if everybody has bugs in software, and if there's a bug in a kernel module, if it's like a dereferencing a null pointer, then not only is your kernel module going to stop working, your entire machine is going to freeze. Crashing the kernel that's your machine needs to be rebooted. So that's a concern. The kernel itself is essentially very field hardened. By the time you use it in production Linux servers, that version of the kernel has probably existed for a few years. It's been used by a lot of people before we start using it in data centers. The difference between eBPF and a kernel module is a process called verification. So as you load an eBPF program into the kernel, this verifier examines all the possible code paths and ensures that it is going to be safe to run, that it's going to run to completion, it's not going to crash, memory access is safe, that kind of thing. So you can have a lot of confidence that your eBPF program is, it doesn't come with the risks that a kernel module potentially comes with.
Right. Okay. So reducing the risk of, because this is, I don't know how much that was happening in Linux, because if we talk about 15 years or whatever, I was mostly Windows back then. Linux was more of a hobby for me. But I remember that there was some statistic that came out of, I think, Mark Rusanovich at Microsoft, was saying that like 80% or 90% of their blue screens of death on Windows were caused by external drivers. And
right. Yeah.
I think of the modules as like someone like Windows drivers. It's like that you're trusting this third party, which is almost always not going to be as good as writing code as the Linux kernel team, and you're trusting them that now your computer is only as safe or as stable as that thing. So So you're saying BPF necessarily gives us is there a way where like you can dynamically load these, right? These are things that you don't need to reboot for.
Absolutely. Yeah, you can dynamically load them, and typically you might load lots of them. So an application like Cilium is loading lots of different small eBPF programs to different parts of the networking stack and so on, and aggregating them together into this sort of networking functionality. I say that there's plenty of examples where you can have a really simple eBPF program. There's a lot of work done, particularly by Brendan Gregg he's now at Intel, but he was at Netflix, when he did a lot of this pioneering work on how you can get tracing information, measure all kinds of different activity on your machine using eBPF programs. So you might attach a simple, very lightweight eBPF program to an event that you want to measure. I don't know how many network packets are arriving or which processes are opening files. And these are very sort of easy to understand, kinds of uses of eBPF that have been super useful and really revolutionized how a lot of this observability, this low-level metrics gathering has been done over the last few years.
I do remember, I feel like for me, the not kernel expert in the room, that I felt like it was a lot of the hype at first was around performance, like that if you wanted to do things that you could maybe do some other way, like tracking the number of network packets, like maybe your network driver had that kind of API or something that you could get that data, but that BPF was allowing a way for a much more efficient use of cycles, and that was way faster. Is that still one of the primary reasons?
Yeah, it can be really, depending on the thing you're trying to achieve, quite often it can be much more efficient to do that in the kernel, because when you transition between user space and kernel, that can be quite costly to make that transition. So sort of you won't notice it if you do it once, but if you do it a million times, it will
Right.
it'll add up. So you can avoid that kind of transition by doing things in eBPF. And sort of asynchronously transferring the information that you've collected into user space.
And so you made some great examples. Like, was it TCP dump? Was that? Well, I'm trying to remember the couple of basic examples of things we probably all used. But one of the titles in this in this video was Cilium. So I should mention to those that are watching that I didn't actually say this at the beginning. Liz Rice, actually, so she is now the chief open source officer of Isovalent, which I was incorrectly saying. So it's Isovalent, everyone. Now you know. And this is a company did they found the Cilium project?
Yeah, absolutely. So in fact, the Cilium project came first, and the same group of people then went on to found the company around that project. So that's kind of the history of it. And now the Cilium project is part of the CNCF. We donated it earlier this year. But obviously it's Isovalent's focus. We're absolutely, Cilium is our kind. I guess we still think of it as our baby. Certainly, the folks across the team have been working on Cilium for years. So there's a ton of really amazing expertise. And I think one of the things that I didn't realize until I joined Isovalent was the extent to which Cilium has actually kind of developed kind of hand in hand with eBPF. So there's quite a lot of eBPF capabilities, particularly on the networking side, that folks at Isovalent have developed in the Linux kernel. One of the two maintainers in the Linux kernel of eBPF is Daniel Borkman, who's one of my colleagues at Isovalent. We have a bunch of other folks who are kernel contributors. And so that kind of the expertise that I get, the privilege of learning from it's pretty amazing in Isovalent.
Nice. And if people don't know, Cilium started as a project exclusively for Kubernetes, right? Does it predate?
Well, actually, no, it predates it. It predates the orchestration wars. I don't know if you remember DockerCon in, I think, 2017. And it was one of the conferences where I did that, building a container from scratch talks. And in the same track, that was where I first heard about eBPF. Thomas Graf, who's the CTO at Isovalent, showing this kind of new project called Cilium that used eBPF to connect containers together. And at the time I thought, well, that's kind of cool. That's interesting. But back then it required a really cutting edge kernel. And I thought, well, it's going to be a while before that's going to be something people can use. People aren't using that kind of level of kernel. That's what's changed in the last couple of years. The distributions that everybody's using have eBPF capabilities now. So, everybody can take advantage of all this eBPF goodness.
Right. Yeah. I mean, especially if you're established. I mean, I just worked with a company last year that was still established, still on CentOS 7, and that was still their platform of choice. And I was working hard to motivate them to do something different. And some of the reasons were that a lot of this container stuff, even on some of the later CentOS versions and CentOS 7, it's still not great with all the support and how much, you and I don't maybe talk about this stuff anymore because we've been talking about this stuff forever, but how much the container ecosystem has affected the kernel. And now I guess what we're seeing is the eBPF observation realm is actually affecting kernel building, and that, the idea that the kernel, for most of us, the kernel just happens, right? We don't even know when things are getting updated or changed, and we just know it when a new version of Debian or Fedora comes out or something like that, and we're like, okay, cool, new features. But every once in a while, we're all lucky enough to try something. Well, maybe not lucky enough, but we're trying something new, and we realize we need a new kernel for that. So, do you know like specific versions? Like, is it something where you have to use Ubuntu 2004 or something? Is it, or?
Well, you're going to stretch my knowledge. I mean, the kernel version, I think it's 4.18 is the kind of earliest version. And I'm kind of 90% sure on that. 4.18 would be a kind of version that starts having really good eBPF capabilities.
Right.
I think that's the version that RHEL is now on.
Yeah.
But I've certainly been using a kernel recently that was sort of 5.13 or 15 or something, because there was some BPF feature that I wanted to use, and I needed a newer thing. So there's a lot of development in the eBPF space, and some of these things in Cilium we've been able to kind of work around. Like, if the feature is there in the kernel, then great, we'll use it, and if not, we need to find a way to sort of adapt around.
Yeah, I was gonna ask you that, because I was actually assuming that that's how it worked, because I remember very much that was like, I cared a lot more about the kernel during the Docker early days, because we were dealing with storage driver incompatibility and various things. Now C groups v2 is all the rage, and everybody's talking about, does your kernel support that? And for a different show. But one of the questions that we have is, where do we use eBPF in Kubernetes? Like, so Cilium is a CNI plugin, right? So it's an optional networking plugin, right? Is there do you know if there's like stuff in Kubernetes by default with just the standard kube-proxy and kubelet and all that stuff? Does any of that use eBPF today, or are we all just...
It doesn't, no.
Okay.
I mean, with the possible exception, you could say, of now that seccomp is supported, but even there, that's not really part of Kubernetes is allowing you to use it, rather than it being a kind of part of Kubernetes, I think. So yeah, I'm not aware of anything that is currently, built into Kubernetes itself that's leveraging eBPF. But as you say, Cilium is a CNI. You have to pick a CNI, and if you want to pick an eBPF one, then Cilium is there for you. Cilium is actually the only CNI that's at incubation or above in CNCF.
Okay.
I think we're in good shape to be on track for graduation next year. So we've got a ton of users. We kind of feels to us, and obviously maybe our perspective is from the Cilium project, but we feel like we're becoming very much the kind of default for people to pick up, because there's no reason not to now. Everybody's got eBPF capabilities. It has really great performance because of eBPF. So the maturity is there because people have been using it for a few years now. So it's I would hesitate to say that it is the default, because you have choices. There are many other options, but it's certainly a solid choice that a lot of people are opting for.
I'm not necessarily one that recommends CNIs to companies, but I feel like I do. I wasn't going to say that, but I do feel like I agree with you. I do feel like that. I see it a lot in distributions as the preferred networking provider. I see it a lot discussed as if you're rolling your own with kubeadmin or whatever, like use this CNI. And certainly when people start talking about network policy and stuff like that, I feel like it is, if not one of the top mentioned ones on the internet, it is the number one. So
and a ton of distributions use it. So the GKE's data plane v2 is based on Cilium. EKS Anywhere is using Cilium. There are others to come in the pipeline very soon. So there's a bunch of managed services that will give you Cilium by default.
Right. One more question on eBPF. Where could you start learning eBPF? And I'm just going to say, well, you could just look at her report that we just mentioned. But that's one thing, right? I guess the docs inside of, is there a I know on the eBPF website, is there like docs for eBPF itself that
Yeah, I would say the ebpf.io site is a good place to find some documentation, and also to find good examples of projects that are using it. The kind of links to conferences and community. eBPF Summit is happening just at the end of this month, 28th and 29th, and that's going to be online. So, it's free and it's online. So if you want to learn about eBPF, that's a great place to join. Also, our Slack channel, we have a eBPF and Cilium Slack community. 13,000 people there now, I think, and it's welcoming. We try really hard to there are no bad questions, and eBPF is not a straightforward. It's not the easiest technology to learn, but it's certainly really fascinating if you're interested in that kind of. It's fundamentally it's kernel programming, but you can get into the benefits of eBPF with a bunch of tools like Cilium, like some of those tracing tools that I mentioned that Brendan Gregg had worked on. There's a whole load of command line tools that you can use and sort of explore and get a feel for how eBPF, the kind of things that eBPF is really good for.
Yeah. My on top of that, I was going to mention that I look at it almost like eBPF. Either there's almost like two types of people I could see, where much like a lot of these APIs, either you're a kernel programmer and you're trying to you know that you need to write something that you're considering whether eBPF can take advantage of it, or you're like me, more of a user, and you just want to use a tool like Cilium. And so maybe learning the tool is your gateway drug to more of how eBPF works, rather than trying to come up with something that, I don't imagine a problem. I always prefer to have a real problem in my real life that I need to solve, and then I use that tool for it. That's to me, that's always the quickest way I learn, is when I really have to use the tool or the thing I'm trying to do won't work.
Yes.
Yeah. So I would recommend that. That's a lot of what my courses try to do too, is we try to solve real world problems for you so that you actually can use these things instead of just know the theory. I
just remembered we also have some labs on Isovalent site. There's a /labs page with a bunch of different instruct-based labs, so you can go into a sandbox and walk through. One of them is about writing your first eBPF program. There's a bunch of things about using Cilium, learning about network policy. I think there's one about cluster mesh. So there's a few different learning scenarios there, and you can walk through those. Learning by doing, which I'm definitely a fan of.
Nice. Labs. Always love the labs. Eric actually asked a question that I was thinking. Maybe you mentioned it or not. Was Cilium always based upon eBPF? Was that, or BPF? Was that its origin?
Yes. Yeah. It was certainly eBPF from the get-go. And the original folks who started the Cilium project were really working on eBPF, and it was a kind of combination of how can we use this new eBPF thing to build the next generation networking stack. And containers was a thing. How are we going to make really efficient connectivity between containers? And they had the vision for, we could use eBPF to. This might be sort of worth diving into. So usually, if you have a container, or in Kubernetes, if you have a pod, most of the time you're going to set that up with its own network namespace. Certainly, that's the default in Kubernetes, and that means that pod has its own networking stack, essentially. So every time you send a packet from one pod to another, even on the same machine, the packet is going down through one networking stack and sort of through the hosts, depending on how the host is configured, and then back up through the pod's networking stack. If you have a packet arrives externally, it's going to go through the host's networking stack and then into the pod's network namespace. We have that virtual Ethernet connection between a host and a container network namespace, and then through the networking stack in the pod. And that's quite a convoluted path. And with eBPF, Cilium is able to say, well, here's a network packet. I know where it's destined for because I set up these connections. I don't need to go through the whole host network stack. I can send it directly. I can sort of pick it off the incoming network stack and put it into the pod's network stack directly and make the path for that packet much shorter. And that's why eBPF-based networking is so efficient, because you can kind of pick and choose which bits of the networking stack you're going through, so effectively.
Is that true for multi-host networking, or is that just like for container to container on the same kernel?
Yeah, so I mean, if you're going to go from one machine to another, you are going to have to go through. Your packet arrives. I think the inbound is the sort of easiest to picture. So your inbound packet is either destined for a pod on this host, or it's destined for a pod somewhere else. And if it's Cilium maintains a hash table of endpoints, and so it's much sort of faster to look up in a hash table rather than going through the whole routing table, going through IP tables. IP tables is the kind of thing that we're able to avoid, really. So, here's a destination address. It's in that pod, or it's on this different machine over here. I am going to have to send it out of this machine. But the other interesting thing in a Kubernetes environment is how pods come and go dynamically, and that means you have to create and destroy endpoints dynamically. Every time a pod appears, it's got a new IP address needs to be assigned to it, and IP tables is not efficient at adding and deleting new entries. It kind of rewrites the whole set of IP tables every time it changes. Whereas with this hash table that we have in Cilium, you can just delete one entry at a time. It's a hash table. So it's much more efficient to keep up with those kind of dynamically changing addresses in a Kubernetes world.
Especially when you're talking like dozens and dozens of IPs per host, which is totally not, 20 years ago. Unless you were a Linux hoster, that's a very rare thing to have in a data center or in typical companies. So this stuff has changed a lot since we've all invented this idea of virtual interface has been around forever, but the idea of like every app gets its own virtual interface. So the thing that we were talking about before the show is how much Cilium can do and how little of that I know that it does. So is there, like, I go to the website, I'm thinking, I'm just going to pull it up. And is there like a list of checkboxes or something of like all the things? Because this list sounds like it does everything related to a packet. Like if it's related to some sort of packet that has to go over some sort of communication, it does it all.
Yeah. And we have these three buckets of networking, observability, and security capabilities. And it is like pretty much everything that you want to do related to those network connections. I think it's always going to be critical to be able to see what's happening in your network, diagnose any issues, understand, if you do have, latency issues, what are the apps that are causing that, or what's the root cause of that? If you have DNS issues, because everybody has DNS issues, it's always DNS. Being able to see, exactly, and the Hubble component of Cilium can show you every packet, every packet that's flowing through your network, and we can build up a service map so you can see how communications are flowing between different pods and services in your Kubernetes deployment and with the outside world. So that part's critical. And then security is, also not just critical, but it's also really efficient when you can build it directly into the networking layer rather than kind of having a separate kind of building it over the top. I'm a huge believer in defense in depth, and I'm not going to say, I would never tell anybody that all you need is network security, but doing a lot of things like network policy incredibly efficiently in eBPF, and now we have this component called Tetragon, which lets us have policies related not just to network policy, but also to other kinds of events, things like file opens or execution, so using Tetragon to say, well, actually, I want to know if somebody touches a sensitive file from within a pod. And if that happens, I want to know exactly which pod, what was the executable that was running that caused that event. And Tetragon can give us all this really in-depth diagnostics, so that if there is a malicious activity, a malicious event, we can, really get the forensics to see how that happened. And there's even the ability to kill processes if they're behaving in a out of policy way, which is it's impressive. It's very smart.
It sounds like it would be hard to do a one-line summary of all the things this does. Okay, so all this is open source so far that we're talking about?
Yeah.
Okay.
Everything.
And
Isovalent does have some enterprise features, but the vast majority of Cilium's capabilities are open source, and we really start getting into enterprise features when we think about things like high availability. There are some power features in the Hubble enterprise version of the UI, that kind of thing. Absolutely, there are plenty of people out there in the world using Cilium open source, in production. So
right,
you can use it for real.
Yeah, if Amazon and Google are already using it for the cloud infrastructure, chances are there's a lot of packets being passed right now through Cilium networks. Is this something where I can? I always thought of with my limited knowledge of Cilium, I always thought of it as sort of it's the basic network. I can make it my basic networking provider. It can do security policies in my Kubernetes cluster, and I always just thought of I'm sure that's just about all it needs to do. And now that I've heard it, I've read on here that we can do ingress with this. So this would replace an ingress provider. Is that true? Or could be its own ingress provider, I guess.
Yeah, you could. I mean, so we have ingress functionality as part of Cilium Service Mesh. So you can do things like path-based routing, routing your inbound traffic. We can do TLS termination. So there's a bunch of ingress capabilities that we can achieve using Cilium. And you don't have to use it for just Service Mesh, but we kind of think of it as part of Service Mesh, really.
Yeah, I was going to mention Service Mesh next, because that's usually to me, that's like the last thing I want people to learn. Not that it's not worth learning. It's just, okay, let's learn networking. Let's learn some load balancing, some ingress, and then maybe we'll talk about Service Mesh, because it's obviously for the last few years, I think I've got some glue Service Mesh stuff on the background there. It's one of those things where I always want to make sure people have the good fundamentals before they start tipping their toes into it, because it can be very shiny, Service Mesh, and I love shiny, so I'm always trying to put the fanciest thing on my cluster, and I'm always surprised at how bad I am at understanding that all the different stuff that a Service Mesh can do. So I take it that when I put Cilium in a cluster, I can sort of opt into some of these things, not all of them. Is it sort of like, does it light up different features as I enable certain things? And is it start with
there's a ton of bells and whistles that you can turn on and off. And we talked about ingress, and there's also egress, which is increasingly something that people need to kind of connect their Kubernetes clusters to some kind of legacy workloads, or they need to go and hit services outside of the cluster. And I think that's another strength that Cilium has. So, for example, you can have network policies that defined in terms of the domain name that you want to reach. So rather than having to say, my network policy, you're only allowed to use this particular port, or you're only allowed to use this particular IP address, you can express it in terms of the example.com that you want to allow or disallow, and that's pretty cool. Also, connecting with things like BGP networks is something that we've seen quite a lot of demand for from enterprise users particularly.
We've got some questions here related to some of that stuff. Ollie's getting pretty technical here, asking about ARP packages. Does eBPF respond to ARP requests for pods? I mean, does node networking respond to requests like ARP, or eBPF will be responsible to do them?
So that's being handled by the kernel, I am saying fairly confidently. You can certainly see those ARP packets flowing. So not, we're handling them. We're passing those packets from, source to destination, but we're not. Actually, I'm saying that. Do I mean that? Having a moment of,
Well,
live.
ARP isn't something that people talk about.
Brain freeze live. Yeah.
ARP is one of those things we all take for granted nowadays. We just assume that it's working. Yeah.
Yeah.
Every once in a while, you do have to troubleshoot. Maybe more way back, 30 years ago, I had to deal with ARP errors and stuff like that. But it's an interesting question. Thanks, Ollie. Throwing us a hard one.
Yeah. I'm sorry, my brain has completely frozen on me on that. I'm going to kick myself after. I'll be like, you idiot.
No, you're fine. You're fine. It's only forever. Like I said earlier, it's only forever. It's fine. Can this replace kube-proxy?
Yes.
Okay.
Absolutely. That's one of those kind of knobs that people can turn as they're installing or configuring Cilium to say, do you want to replace kube-proxy?
Yeah.
And that avoids the IP tables issue in a big way.
Yeah. Because I'm sitting here thinking, if I'm going to use it, I probably would want to do that because I'm assuming that tighter integration. But yeah, that makes sense. Totally, the IP tables is all a part of the kube-proxy. I'm saying this pretending like I'm smart, but I'm not. Martin asks, does Cilium help with zero trust? Which is, does that need to be a yes or no question?
Yeah, that's a kind of, yeah. So I think zero trust is quite a difficult thing to define. Certainly, you can, for example, use network layer encryption between all your traffic using Cilium. So using either IPsec or WireGuard. And, that means all of your traffic is encrypted, and that is certainly a big step towards zero trust. We don't today have MTLS in between individual workloads automatically supported, although that is something that's authenticated, cryptographically secure connections between workloads is something that we're working on right now. So it kind of depends on exactly what you mean by zero trust when you ask that question.
Yeah. I mean, the first thing that comes to mind for me is, like you said, the automatic encryption, so that I don't have to trust the physical infrastructure, especially as we start talking about multi-cloud or hybrid and stuff like that. Martin asked another question. Cilium does multi-cluster, but can you non-cluster services?
Non-cluster services. So we should probably talk, multi-cluster. It's implemented in a really nice way in Cilium. It's almost too simple, just kind of define services with the same name in multiple clusters. And it might also be you might need the same labels. I'll check on that. But essentially, you define the same services in two different places, and you just say, yep, these are global, and they can be shared across clusters. And since the most recent release, you can also do, which is 1.12, you can also do kind of affinity. So you can say, well, I would prefer to use the service in my local cluster, but should it not be available, then I can, revert to using the same service in a different cluster. Can you non-cluster services? You can certainly use external services. So, that's kind of the egress things that we were talking about before. And we have egress gateway as well. So you can, if you're used to the idea of kind of firewalling external traffic, you can, normally you wouldn't know what IP address your request was going to come from because it's, pods have those dynamic egresses, but the egress gateway means you can know that your egress traffic is going to come from a certain set of IP addresses, and then you can configure your firewalls accordingly.
Are there components of this that run outside I mean, when I think of non-cluster services, I'm thinking non-Kubernetes services. Is this like a Kubernetes focused tool now where you don't really use it outside of a Kubernetes cluster, or?
There are people using it, and actually I saw a question, Moz's question there about whether Cilium supports north-south load balancing. We have quite a few users using Cilium in a non-Kubernetes environment for load balancing. So yeah.
Okay.
2 questions, 1 answer.
Yeah, that one's a good layup there, Moz. Thank you. Yeah, so is this something that where we might see other services and clouds that they're just wrapping Cilium up like for a load balancer thing, or because like right now I think of it as either your distribution comes with it or you're building your own, which I don't recommend, but if you did, that you would choose this as your CNI and then you'd choose all the bits you enable. And so when I traditionally, due to my ignorance, I would think, okay, if I choose an AWS cluster option that they give me, it's going to come with Cilium or not out of the box, and I will just use it. Is there like other things outside of Kubernetes clusters in the cloud that, like when I think of load balancing, I think of like, external load balancers at Amazon or, any of the other cloud providers?
Yeah. So I don't know if anybody has sort of wrapped it up as a product like that. I do know that people are replacing physical load balancers with eBPF-based load balancers in Cilium-based eBPF load balancer because it's so efficient. One of the things that's very cool. This is a little bit of a digression, but I think it's super interesting.
Yeah.
So there's the thing called XDP, which is part of eBPF, and it stands for Express Data Path. And it's a hook where you can attach eBPF programs that is very close to the network packet arriving. So close, in fact, that it can actually be offloaded into network card. So if the network card supports it, you can run those XDP programs, those eBPF programs that are triggered by an arrival of a network packet, can run on the card itself.
Right.
And so for things like load balancing or filtering, like DDoS protection, it's super efficient. That packet is dealt with, never got anywhere near the CPU. So it's really cool.
That is actually pretty cool. And of course, those of us that have been around long enough, I mean, nowadays, if you're just a cloud engineer and you never had to deal with hardware in the history, you maybe don't realize that there is this CPU or network CPU essentially on the card. And I remember back in the day when we didn't really have powerful CPUs, we didn't even have multi-core, that like making sure that your driver was enabling the NICs CPU was so important, because otherwise you wouldn't get anything near the wire performance of your network. And it's sort of just done for us nowadays. Like we just get these servers and they're already enabled. But that's actually really cool. And so your tools can see that, right? It's not like you're losing visibility, right? Like you're just offloading performance to yet another specialized CPU on the machine.
Yes, I mean in that example for sure. Yeah. I don't know if there are any other kind of specialized eBPF hooks on dedicated hardware, but maybe there are.
Yeah. All right. So another question for me, because I'm pretty new at this. Is there like a fancy web GUI that I get to like look at some of this observability stuff? Is that something that comes with Cilium, or how do I get those things?
There's the Hubble UI, which Hubble comes with the CLI, so you can, if you're comfortable with, the terminal, or you want to, manipulate that output as it's generated, then the CLI is your friend. And then there's the UI, which is probably, I would say, most useful for seeing things like the service map. So, and there's also a thing called the Network Policy Editor, which is on networkpolicy.io, which you can use for visualizing how your network policy is going to affect traffic in your cluster. So it's quite a nice way of building those network policies. It's certainly very visual. The other visual thing that we have is not really a Cilium thing, but we generate Prometheus Metrics, and there's some nice Grafana dashboards that you can get really good, insight into how your network's performing. You can see, I don't know, TCP packets being dropped, or HTTP errors, or latency graphs, that kind of thing. That's the network policy editor.
Yeah, it looks like we got a couple of ways into that.
There's
policy IO. I didn't know about this. This is awesome. I mean, because sometimes when you're doing concepts and stuff like that, you're having a hard time understanding all this and all these features and how they affect. So I'm always trying to add more visualizations. And hey, we're on YouTube, so we get to add pretty things on the screen. I'm just going to throw some of these links in so people can dive more into the network policy and this editor stuff. So because that's one of the challenges, right? I think overall with Kubernetes is you're building you can build a data center level network complexity inside of a single machine now. And most of us, like most developers that were developing their app, never had to deal with so much network complexity because there's usually someone else doing their job. And now suddenly we're throwing even more of this YAML and these policy editors and all this stuff at the DevOps people, at the people that weren't traditionally the network people. Of course, if you're in a very, very big team, I'm sure that there's network dedicated people that are already, updating the physical infrastructure with their own code. And I used to, way, way long ago, I was a Cisco network engineer. Those days are long gone by, so I've lost most of that knowledge, and I barely remember what a TCP packet is now. So I think actually we missed something from Eric. He said something about ARP. Oh, he was just saying ARP is a low level in AFAK.
I'm thinking about it now. I don't think it does show ARP packets. I think it's TCP. I think ARP is the layer below.
And Maz is asking another relevant question on, is it possible to do layer 7 filtering at the eBPF layer XDP hook? Oh, for our...
So the answer is a kind of qualified yes. So when in that XDP hook, you have the packets, and if you want to write something that can parse that packet, then absolutely. Parsing layer 7, it's more complex. We do have, and this is actually an example of an enterprise feature because it's super kind of performant. We've got an internal HTTP parser for observability purposes. Mostly, so in the open source version, we use Envoy for layer 7.
Oh, okay.
So if you want to see the URL that your packet is asking for, we use Envoy to do that in the open source version, but it is possible to do that in eBPF. I don't actually know for a fact whether it's done in an XDP hook or somewhere else slightly higher up the stack. I think that's an implementation detail. But certainly you have that packet in your hand and you can do anything you like with it if you it's just writing the code.
Right. And that's cool about Envoy too, because a lot of times people may have heard of Envoy and not necessarily heard of Cilium yet, or vice versa. And it's sort of because that's another project. I'm not sure if we've had them on the show, but I've been using them more over the last few years in projects as getting people off of Nginx and into other options that maybe are more fitting for their particular scenario. And that's been one of the projects, I think. And I think actually we have had someone from that team on the show, but it's been so many. There's been so many projects on the show these last few years. I forget.
Yeah. And it's used a lot. I mean, it's a powerful proxy, and I think a lot of projects use it.
Yeah. Certainly wrapping it up in other tools. And so when we talk about like the load balancing stuff, is that because there's the words load balancing are mentioned all over the site. Is that just some of this stuff? Is it like a little bit everywhere? Is there some of it that's in the XDP stuff, and there's some of it maybe in the Envoy? Because that, when I think of like layer 7 or ingress load balancing, I think of a proxy. So I guess load balancing is kind of a generic term here, because I was about to ask you, where's the load balancing go? But that's kind of a big
the load balancing is which bit? We talk about service load balancing. The kube-proxy replacement is load balancing. There's one of the interesting things when I first joined Isovalent, we were talking about the concept of Cilium service mesh, and when you think about, well, Cilium already has observability, it already has a ton of security features, it already had load balancing. That's covering a lot of bases that you expect from a service mesh, and that was kind of the beginnings of that project.
Okay, yeah, that makes sense. I think one of the things after people get through, like maybe let's say my Kubernetes 101 course, or if you take a workshop or something, we kind of glaze over all this networking stuff, because a lot of it is optional to a developer that may not have to ever care about any of this stuff. It might be taken care of by another team, the DevOps team, the networking team, the DevSecOps team, something like that, where they're defining network policies. They're deciding on how you're going to do layer 7 ingress and what the security groups are and all the other things that we think of when we think of networking security. So I hate to always teach it, even though this is a lot of cool stuff. I'm afraid to teach it on day 1 or 2, because I don't want people to think you suddenly got to care about all things observability and networking. But as people mature, and so those of you watching, if you're sort of in you're more than your first week of Kubernetes and you're maturing, I really feel strongly that like networking, more than storage even, is kind of that area where we're all working in distributed computing now. Every app we make is probably a distributed app at some level, and we need to invest more time in networking. I don't know where you originally learned your networking, but I learned it, I think, in the 90s, sitting in a Barnes & Noble reading a TCP/IP Unleashed book, because I was too poor to actually buy it, because I think they were $75 or whatever, and they were this thick, and I was just going to sit there and read the book, and I did, and that's how I learned it. I don't know if you remember exactly what you learned about what a TCP packet was.
My first sort of postgraduate job was working for a company that wrote network protocols. So wrote stacks. So, and in fact, for the first few years, I didn't do anything on TCP/IP. It was all SNA. So this is like IBM mainframe emulation stuff and or client emulation. So my early career, there was a lot of networking, much of which I kind of, it was a bit of a challenge to try and remember it all again, coming back to the networking world.
Yeah. In fact, I think often that I just really need to go back and reread a TCP book or a TCP/IP book or something that's, because it's the protocol. I got in back, sounds similar to you, that back when it wasn't always going to be TCP, UDP, and ICMP packets. Like these weren't necessarily the default back in the day. We had a lot of other protocols.
I worked on ATM, I worked on MPLS. It was there were lots of different options.
Yeah, lots of ideas. Thin net, thick net. Yeah, it's everybody had their own way of getting things from one server to another. And I think that now that we've pretty much standardized on this protocol, at least outside the data center, that for those of you out there, if you're trying to learn this stuff and you haven't taken networking fundamentals, if you haven't gone back and had to remember exactly how subnets work, and sorry for the jet noise, exactly how, what's the proper size of a packet? Like, what's the default size? Like, what are these NIC card CPUs that we're discussing? Like, what does that mean? And virtual interfaces in Linux. And like, these are the concepts that Linux and Kubernetes are all built on. So I find it really helpful. This is sort of a soapbox moment for those that aren't yet doing that don't expect to go into eBPF and start being a whiz if you still are struggling with, what exactly is the difference between a TCP and UDP packet. So there are great networking courses out there. I don't teach them. Sorry. I wish I had a networking course. I also wish I had an eBPF course, but I don't have any of these things. So take those before at least as part of this, because I think that these all go hand in hand, and I think it's a really good refresher, even for those of us that have been doing a long time. Eric's on there throwing out every protocol: NetBIOS, NetBEUI, I hated NetBIOS.
X25, I remember. Yeah.
Yep, X25. X25 for me was always one of the ones that either worked or didn't. NetBIOS was the kind of one thing with Windows where it was like it sometimes works, it sometimes doesn't. You have, yeah, strong memories. Any other questions, anyone in the audience? We're going to start wrapping this show up. And so if you get your last questions in, I think there's a question from Kumar there. Should we store the eBPF bytecode or the code before the CLang compiler? Okay, this is definitely something I know nothing about. So,
I know why this has come up. There's been a project that talks about storing eBPF programs in pushing them into OCI registries, a bit like Docker push, which is on the face of it, why not? I mean, this is code. Why should we not store it in a registry? I quite like the idea of general purpose registries. The thing about eBPF is you typically have a lot of these very small programs, and they're usually customized in some way before that. So, for example, you might have you're going to need a different eBPF program for every network interface, and that includes every virtual interface. So, for every pod, and they are typically kind of customized at the point before they're loaded. I mean, you could store them in a registry, pull them from a registry, modify them, and download them. But I think that's it. There's usually more complexity. That there isn't a one-to-one mapping between I want to do a thing, I'm going to pull an eBPF program. There are dozens and dozens of programs, eBPF programs involved in Cilium, for example. So I personally, I've not actually seen anybody using the OCI registry storage idea as a, in a production environment. What has happened, one of the kind of more recent developments in eBPF is a thing called compile once, run everywhere, where it essentially makes eBPF programs compatible across different kernel versions. And I think that will lead to the idea of, perhaps having a general purpose store for eBPF programs might start to be more realistic, but it's certainly not something I've seen today. The answer to whether or not you should store the eBPF bytecode or the code before Clang compile, the code before Clang compile is the source code.
Yeah.
I don't think people normally store source code in registries. I mean,
yeah,
I guess you could. But most distribution of eBPF programs, I would say there's a user space component or some number of user space components, some number of eBPF programs. They're probably delivered as a container image or, maybe as a package that you can install into your, Linux distribution or even Windows distribution now that eBPF for Windows is becoming a thing.
All right.
Yeah. I'm unlike you. I'm very much like I sort of deal with Linux, and I believe that there is another operating system called Windows. So I get very out of my depth very quickly.
Well, my BSD fans are going to say, "Hey, don't forget about my BSD."
Oh. Yeah, Solaris forever. Yeah.
That's right.
The eBPF for Windows is a thing. Microsoft have been working on that. And they have done some demonstrations of Cilium running on Windows, which is pretty exciting. So
I do get a surprising amount of people asking about Windows servers, Windows containers. It's still a thing. I wish it was more popular than it was, but doesn't mean people can't use it. So it's excited to see parity whenever, like when the Kubernetes finally announced that kubelet and kube-proxy all had like parity on Windows. I don't know what was 116 or 118 or something like that. That was exciting for me because I knew that there was people struggling to move to more advanced than just Docker. They were wanting to implement Kubernetes on Windows servers. So I know there's definitely a thing. And well, we're gonna have to wrap this up because we're over the hour. But I was thinking about just the the general landscape of all this stuff in Kubernetes, it sounds like this is basically implemented through the standard stuff we expect. Like, I'm guessing the configuration is stored in a config map, and the applications come as either an image or, as like you said, as a host package that you have to make as a part of your Kubernetes install, maybe.
I mean, for Cilium, it's containing images. You know, there are different images for different components, but your Helm charts. There's also quite a nice CLI tool that you can use, and particularly if you're experimenting with Cilium, the CLI is a really easy way to kind of
get started. Okay,
install really easy.
Yeah, very cool. Somewhere in the future, we'll maybe have to have a Cilium demo of installing and getting set up on Kubernetes. But that's not for today, because we were focusing on the eBPF side. So thank you so much for being on the show. We could go on forever. I don't think we saw any more questions. People had their warning, other than the competition to see who can remember every old protocol that doesn't exist anymore, or it doesn't. And let's see. Yeah, I think that's it. Yeah. So, well, let's mention all the things real quick. Liz, you have the books. We're going to talk about the books on your website. And you have a bunch of other stuff there, like links to talks, because she's constantly talking at conferences, including probably this week, next week, every week until KubeCon. Which
I'm really bad at keeping that talk list up to date. Somebody did suggest to me recently I should just open source my website so that people can update it for me. And if
that's a great idea.
The only thing is the time taken to move it from one framework to another. But,
your book image is outdated. I'm going to replace it for you. Every once in a while I get wonderful little PRs like that, so it's always appreciated. We're all struggling to keep this stuff up to date. And you're going to be at KubeCon, right, in Detroit? So I'm going to be there. And so for people that are interested, I mean, we'll be around. Ping us on Twitter. We both are on the Twitter, and let us know if you're going to be there. I'm going to figure out something for our community here that we can all meet up at some point during the conference, but I haven't figured out exactly what I'm doing yet at the conference. So that's forthcoming. Come back next week. Let's see what is next week. We've got I should have been more prepared. Next week is the monthly Udemy course Q&A. So I'll be back here, sadly, without Liz, without a guest, and I will just be taking your questions on all things my Docker and Kubernetes courses. So come back if you're in those courses and you have questions. We will talk about just about everything container related. And then after that, we have Lee and Nick talking about service mesh. On the show, we're going to talk about the Meshery project and some other neat service mesh things. So that's keeping on theme a little bit with what we talked about today. And then we've got Rosemary coming back from HashiCorp to show us more HashiCorp projects, because everyone loves all the HashiCorp projects, and we haven't gone through all of them, weirdly, in 3 years. I still haven't finished all of the things. I don't even think we've ever had a single one on Terraform, which is, I think, basically a sin at this point. So we need to get more...
adding projects and that kind of... How can you keep up?
Yeah, I know. I'm trying to. That's why Rosemary's coming back, because she was here earlier this year, and we didn't talk enough about everything, so we're going to have more of that. So thanks everyone again for being here. Again, we'll be here live next week, same time. Thanks, Liz. See you soon.
Bye.